is an example of an projectile motion. So in this problem, we have an object that is thrown from the top of a building toward another building 50 meters away. So the initial velocity is 20 meters per second at the angle above the horizontal. So the initial angle also is 40 degrees. So the initial position of the ball in the XY reference frame is 0, 0, 0. So this means that this position will be taken as the center of the reference system. So the first question is write the equation of motion. Now, this is a projectile motion. It's a straightforward problem. We know that in the projectile motion, once the object is released with this initial velocity, so it is subject only to a gravitational force, which is a vertical force. So if we go along the x and y axis, the motion, we separate the motion along the x and y axis. We know that the acceleration along x is equal to 0 because there is no force acting on the object on the horizontal direction. And then the initial velocity is a constant. So the velocity is constant since the acceleration is 0. So the velocity will be the projection of the initial velocity along the x-axis. And then the position will be the integration of the position, which means of the velocity, which means v0 cosine theta and everything times time. So this is the equation, or these are the equation of motion along the x-axis. Well, along the y-axis, we know that the object is subject to the gravitational strength or the gravitational force, which means the y acceleration is equal to minus g. So we know that along the y-axis, the object is subject to the gravitational force. Since we are taking our y-axis upward, direction of the y-axis is upward, then the acceleration will be in the negative direction. It will be equal to minus g, and g is 9.8 meters per second. This is the usual gravitational strength. Okay, so then we can integrate to go to the velocity along the y-axis. Well, the velocity along the y-axis is equal to the initial velocity along the y-axis, which is the projection v0 sine theta, and minus the integral of the acceleration, which is gt. And then we can also go to the y position of the object, which is also the integral of the y, velocity, or the velocity along y. Well, if there is any initial position, we start with it, and then plus the integral of this term theta, and then minus 1/2 gt squared. So these are the equation of motion along the y-axis. Now we know that according to what has been given to us, we will take the x0 and y0 as 0, so this will be equal to 0. So this is 0. So now we have an equation of motion. Let's give the numbers. This is equation 1, this is equation 2, this is equation 3, and this is equation 4. So that when we do the analysis, we will be able to refer to them. So this is the first question, A. Now the second question is determine the horizontal position at which the ball will reach the maximum height. So we are talking about this position, because at this position the ball will reach the maximum height. So we are talking about this xm. We want to find the horizontal position at which the object will reach the maximum height. What is the maximum height? So we know that the maximum height is reached for this projectile motion and also for the free fall object when the velocity along y is equal to 0, because the object is going upward and then it loses its velocity becomes 0, and then it goes down. So the velocity is equal to 0, the upward velocity. So this means that from equation 3, we can easily see that the time at which the object will reach the maximum is equal to v0 sine theta divided by g. So this is the time at which the object will reach the maximum. Now we can calculate its value, or we can also keep it for later. So what we will do then, we will just plug this equation into the x-axis. So x, which is xm, is equal to the v0 cosine cosine theta. This is from equation 2. And then we replace by its value, V0 sine theta divided by G. Okay, we replace by this, and this will give us the V0 squared sine 2 theta divided by 2G. Well, the reason is that sine theta cosine theta is equal to sine 2 theta divided by 2. Okay, this is well known from high school. So now the xm, if we replace by the values, the v0 is 20 meters per second, theta is 40, and g is 9.8. You can see that it is equal to 20.1 meters. Okay. Now this is question B. What is question C? At what time does the ball cross the horizontal axis? So we are looking at the time at which the ball will cross the horizontal axis. This means the horizontal axis is this. So this means we are talking about this point. At which point, because the horizontal axis is the point, is the axis or the ground level from where we threw the ball. So what happens at this position? Well, at this position, we can easily see that the y position is equal to 0. So we have to solve the problem or the equation y is equal to 0. So question C, we need to look at to solve the equation y equals 0. Now y is equation number 4, which is v0 sine theta t minus 1/2 gt squared. Well, you can easily see that if we put time in common, this gives us minus 1/2 gt is equal to 0. Either this equal to 0, which is the initial condition at the moment when we threw the ball, the time is equal to 0, or this one is equal to 0. This is exactly the time we are looking for. So this way, you can see that this will give me the time we are looking for is is equal to 2 times v0 sine theta divided by g. Okay, so this is 2 times 20 sine 40 degrees, and then divided by 9.8, and it gives you a time is equal to 2.62 seconds. This is the time we are looking for. Okay, now let's go for the last question. What is the coordinate YF of the ball when it hits the other building? So we are looking at this coordinate. So how do we find this coordinate? Well, we know at this time or at this position, the distance along x is 50 meters. So all what we have to do is to solve the equation, this equation equal to 50 meters. Okay, so the question D is x is equal 50 meters, at which time the ball will reach or will be away 50 meters away from the building, from the initial position. So we know that from equation 2, time. So this means that the time at which it will reach 50 meters is equal to 50 meters divided by v0 cosine theta, and you can easily see that it's equal to 3.3 seconds. So what? Okay, so we know 3.3 that YF will be reached after 3.3 seconds. So all what we have to do is to replace by each value. So we know that the y position is equal to this equation, which we already determined. Okay, and if we replace with t equal 3.3 seconds, so we will find that the y position, yf, is equal to minus 10.93 meters, which is to be expected because our horizontal axis is above this. Okay, so the last question is to calculate the velocity of the ball at that time. Okay, So the velocity of the ball at that time. So let's look at the velocity, the total velocity at time 3.3 seconds. Well, right, this is what we were talking about, yeah, the velocity of the ball. So the velocity, if we want to calculate the velocity, all what you have to do is to replace at the x position, the x direction v0 is cosine theta. So the velocity is constant, is 15.32 meters per second, and Vy is equal to V0 sine theta minus gt, and t is 3.3 seconds. So we can easily see that Vy is equal to minus 19.48 meters per second. This is to be expected. Why? Because so the velocity along the y-axis is negative, and the velocity along the x-axis is positive. Well, this is to be expected because we can explain it in the figure. Because when the object, well, this is to be expected because the velocity at this point, this is the velocity, this is the direction of the velocity. You can clearly see that along the x-axis, the projection is positive, and along the y-axis, the projection of the velocity is negative.